Welcome to this explainer. Okay, let's jump right in. Imagine for a second being able to build massive, globally scalable applications without ever once having to buy, maintain, or frankly even think about a server. For decades, right, deploying software meant wrestling with underlying hardware, patching operating systems, and doing all this tedious capacity planning. But a pretty radical shift has happened in cloud computing. So today we are diving into the fascinating world of building invisible infrastructure. You might know it better as serverless computing. If you're looking to deploy code way faster, drastically cut your costs, and literally eliminate infrastructure headaches, you are in the perfect place. Now, when people first hear the word serverless, it kind of sounds impossible, right? Like, how on earth can code run without a server? Well, think of it this way. It's like having a magic genie that appears, does the work, vanishes, and you only pay for the wish. That is the ultimate promise of serverless computing. It's not that servers have actually ceased to exist. They're absolutely still out there in a data center somewhere. It's just that they have become completely invisible to you as the developer. Here's our roadmap for today. We're going to start with the invisible kitchen analogy to set the stage, then trace the evolution of the server. After that, we'll check out some real-world superpowers this tech unlocks. Then we get to the really fun part, building a URL shortener from scratch. And finally, we'll talk about your very own magic genie. All right, kicking things off with Section 1, the invisible kitchen analogy. Before we look at any code, let's get our heads around the big picture. Think of the software world like running a restaurant business. Using microservices, that's like breaking one giant restaurant into smaller, specialized kitchens. You know, one just for pizza, one for burgers. It's great for big apps, but kind of hard to manage. Now add Kubernetes to the mix, and it's like you've hired a super manager to organize all those chefs. It's incredibly powerful, but highly complex. But serverless? With serverless, you don't even own the kitchen. You just order the food, a magic genie cooks it instantly, and poof, the kitchen completely disappears. It is perfectly designed for simple tasks and has a super low barrier to entry. So let's pin down a formal definition here. Serverless computing is all about running small pieces of code only when they are needed, paying exclusively for the execution time with absolutely zero server management. You'll actually hear this called function as a service a lot. You just write a single function, maybe it's a file processing script or a quick database query. When a user clicks a button, boom, an event triggers, the function wakes up, does its job, and goes right back to sleep. The cloud provider handles all the provisioning, all the scaling, the whole shebang. Moving on to Section 2, evolution of the server. We really need to see where we started to appreciate this. Just look at how this deployment journey has evolved over the years. Back in Era 1, we had bare metal. You literally had to physically buy a server, rack it, install the OS, and manage all the patching manually. It was an absolute nightmare for your time. Then Era 2 brought us virtual machines. This definitely optimized our resources, but guess what? You still had to configure the environment and patch those operating systems. Era 3 gave us containers, popularized by Docker. You packaged your code and dependencies together, awesome for portability, but you still had to manage those containers and, crucially, pay for idle time. And that brings us to Era 4, serverless. The underlying stack, completely handled by the cloud provider. Your only focus is just writing your business logic. And because you are hyper-focused on just the business logic, the benefits are honestly staggering. First off, you pay for execution only. That means zero idle time. If nobody uses your app on a Tuesday, you pay nothing on Tuesday. But when users do show up, it auto-scales automatically, effortlessly going from 1 user to 1 million, all while staying highly available and fault-tolerant across multiple regions. Plus, your time to market is ridiculously faster. And it's a polyglot environment, meaning you can write these functions in pretty much whatever programming language you want. All right, Section 3, real-world superpowers. Let's look at who is actually using this invisible infrastructure. Spoiler alert, it's the biggest tech giants on the planet. Take Uber. When you request a ride, a tiny serverless function instantly matches you with the driver. During rush hour, when millions of requests are flooding in, the system handles that massive spike automatically. But at 3 a.m., when the city is asleep, Uber is paying almost nothing because the functions just aren't running. Instagram and Facebook do the same thing. They use serverless functions to process filters and notifications instantly, rather than keeping thousands of idle servers humming in the background. Even everyday websites use them for things like contact forms and chatbots. The code only runs when you actually hit submit. And right now, generative AI applications are leaning hard into serverless to scale these massive event-driven workflows for large language models. Now, I mentioned earlier that you only pay for execution time, but I really want to put that into perspective. Check out the number 100. Serverless functions are billed by the millisecond, and a typical task often takes just 100 milliseconds to complete. Just think about that for a second. You are paying fractions of a cent precisely for the exact fraction of a second your code is actually running. It is literally the ultimate evolution of cost efficiency.
Okay, enough theory. Let's get our hands dirty in Section 4, Build a URL Shortener.
If you want to test the waters of serverless yourself, building a URL shortener, basically your own personal tiny URL, is the absolute perfect starter project. It's super beginner-friendly, it actually solves a real-world problem, and you can knock the whole thing out in just 30 to 60 minutes. And the absolute best part? You can build and host the entire project for exactly $0.00. No way, right? Yes way. Here is the 3-step game plan using completely free tools. Step 1, head over to the AWS free tier and create a tiny Lambda function. You just write a few lines of code, Python, Node.js, whatever, that takes a long, ugly URL and generates a short one. Step 2, you store that mapping, so the long link and its short buddy, in a free AWS database called DynamoDB. Step 3, you add an API gateway trigger. Think of this as the front door of your app. When someone clicks your new short link, this gateway basically rings the doorbell, wakes up your Lambda function, checks the database, and redirects the user instantly. Now, the true beauty of the serverless ecosystem right now is how flexible it is. You've got options. You can take the AWS route. If you create a free account, Amazon literally gives you 1 million free Lambda requests every single month. You could be shortening links all day, every day, and your monthly bill will literally read $0.00. But hey, if setting up an AWS account feels like a bit too much friction, no worries. There's the no account route. You can use platforms like Cloudflare Workers, which has an awesome completely free tier, or Vercel Serverless Functions, which are famously brilliant for beginners. The barriers to entry here are completely gone. Which brings us to our final stop, Section 5. Your magic genie awaits. So we've seen how serverless has totally stripped away the complexities of bare metal servers, virtual machines, and container orchestration. It hands developers the absolute superpower of instantaneous scaling, millisecond billing, and fault tolerance, all while keeping the actual infrastructure totally invisible. You no longer have to rent out the entire kitchen just to cook a single meal. So as we wrap up this explainer, I want to leave you with this one thought. Now that you have a magic genie waiting to run your code for free, what are you going to build first?